Hey everyone, welcome to my channel. My name is Harshad Bagul. This is our very first video on product design and development, and today we are starting with Unit 5 Design Verification and Validation. In this video, we are understand what verification and validation really mean, why they are so important in the product design process, and how they ensure that the final product meets both design specification and customer need. If you are a mechanical design or production engineering student, this series will help you easily understand every topic with simple explanation and example. So make sure to subscribe, hit the like button, and let's get started with Unit 5 Design Verification and Validation. Syllabus is FEA, CFD, MBD, FSI as shown in the slide. So read this. So go to next slide. These are the question papers of previous years: April May 2023, April May 2024. So start with the first topic, finite element analysis method for complicated mechanical design. Finite element analysis FEA is essentially a systematic computerized method of analyzing the effects of electromagnetic field, mechanical traces, prolonged heating, thermal shocks, and other payloads on mechanical products and their components. Typically, a standard finite elements analysis technique include durability or failure analysis, tolerance and dimensioning analysis, design optimization, and various other tasks. FEA methods are mostly performed with software that deliver through the analysis of functional and physical aspects of a system, material, mechanism, design, or product. So next, the advantages of FEA in compliance with mechanical designs. The advantages of finite element analysis are huge. For example, it can be used to demonstrate a new design concept that will help the engineering team predict its possible real-world behavior under diverse load environment. Based on this analysis, any suitable alternation can be easily made before finalizing the drawing, and once the detailed CAD model is developed, the product engineering team can analyze the detail with FEA, thus saving time and resources by limiting the number of prototypes required. Apart from that, any existing product that has been facing a field problem or is undergoing upgrade can also be analyzed to speed up the process and limit the cost. So this is the advantages of FEA in compliance with mechanical design. So next, the biggest strength of finite elements analysis technique is the sensitive software used to deliver in-depth and precise analysis of various physical and functional aspects of material, system, products, 3D CAD design, etc. For example, how a washing machine would operate or how durable its agitator would be. All these answers can be derived from FEA. So next, finite element analysis methods are essential for design consultants, original mechanical equipment manufacturers, fluid machinery equipment designers, research and development designers, civil engineers, and satellite and missile development programs. FEA techniques are applied to solve a wide range of problems, but by far one of the most common applications are structural FEA that can predict how a solid body would respond to electric, magnetic, or mechanical forces. The structural FEA of amounts to pinning down the industrial governing equations that represent the material and its important characteristics, and then solving those equations for their corresponding physical components. Next, how FEA works. First is pre-processing. This is the opening phase of the FEA process, the one in which the team of analysts develop a finite element mesh to segment the subject geometry into multiple subdomains to allow mathematical analysis. The analysts then apply the important material properties as well as boundary conditions to each of the subdomains. The ultimate goal of this phase are to bring forth an accurate finite element mesh, allocate felicitous material properties, and designate boundary condition with loads and restraints. Second is solution. In this phase, the software used in FEA process derive the driving matrix equation from the model and solve in them individually for all primary quantities. While both pre and post processing phases are time consuming and interactive by nature, the solution phase is more of a batch process that relies heavily on computer resources. So third is post processing. This is the third and final step of all FEA methods. After a finite element model is created, tested, and the entire model is solved successfully, the team of analysts monitor the validity of the solution in addition to closely examine the values of all primary quantities like stresses and displacement. They then extract and test the additional quantity like error indicators, specialized stresses, etc. This is the analysis of FE analysis of a part. So all the condition are covered in this part. So watch this. So next is computational fluid dynamics. Computational fluid dynamics means CFD is a science that with the help of digital computer produces quantitative predictions of fluid flow phenomena based on the conservation laws governing fluid motion. The key to various numerical methods is to convert the partial different equations that govern a physical phenomena into a system of algebraic equations. Different equation, different techniques are available for this conversion. CFD is merely a tool for analyzing fluid flow problems. If it is used correctly, it can provide useful information cheaply and quickly. So next, this is also a numerical flow. So next is numerical flow analysis using CFD. Computation means computational fluid dynamics. CFD is applied to a wide range of research and engineering problems in many fields of study and industries including aerodynamics and aerospace analysis, hypersonics, weather simulation, natural science and environmental engineering, industrial system design and analysis, biological engineering, fluid flows and heat transfer engine, and combustion analysis, and visual effect for film and games. So next is multi-body dynamics means MBD. Multi-body dynamics or multi-body system simulation is the study of motion of mechanical system caused by external forces and motion excitations acting on system. MBD is incorporated with FA, which helps in reducing the time required with the same level of accuracy, neglecting things like meshing and boundary condition. Study of MBD is the analysis of how mechanisms works under the influence of forces. So next is industrial application including automotive, aircraft, defense, military, spacecraft, robotics, agriculture, construction, manufacturing, etc. Engineering judgment is made based on the analysis done using embedded simulations. So next is this is the multi-body system. First is force element, global and local reference frame, then points, markers, rigid and flex bodies. Next is joints and motion. So come to next slide. So equations governing MBD simulations. The whole idea of MBD was developed on Newton's second law of motion. The equations of motion are used to describe the dynamic behavior of multi-body system. Each multi-body system may lead to different mathematical appearance for the equations of motion, while the physics behind is the same. The equations are written for the general motion of the single bodies with the addition of constant condition. So come to next slide. Fluid structure interaction FSI. Fluid structure interaction FSI is a multi-physics coupling between the laws that describe fluid dynamics and structural mechanism. This phenomenon is characterized by interaction, which can be stable or oscillatory, between a deformable or moving structure and the surrounding or internal fluid flow. Come to next slide. When a fluid flow encounters a structure, stresses and strains are exerted on the solid object, forces that can lead to deformations. This deformation can be quite large or very small, depending on the pressure and velocity of the flow and the material property of the actual structure. So this is a structure as shown in the diagram. Come to next slide. If the deformation of the structure are quite small and the variations in the time are also relatively slow, the fluid behavior will not be greatly affected by the deformation, and we can concern ourselves with only the resultant stresses in the solid parts. However, if the variation in the time are fast, greater than a few cycles per second, then even small structural deformation will lead to pressure waves in the fluid. These pressure waves lead to the radiation of sound from vibrating structure. Such problem can be treated as an acoustic structure interaction rather than a fluid structure interaction. So come to next slide. Simulation driven design. This is a simulation driven design. First is system modeling, second is 3D concept and manufacturing. Generate, simulate, analyze. This is the process of simulation driven design. So next slide. Simulation driven design is defined as a design process where decision related to the behavior and performance of the artifact and significantly supported by computer based product modeling and simulation. So this is definition of simulation driven design. This is the video for more information about simulation driven design. So go and watch to know more about simulation driven design. So go to next slide. So additive manufacturing. Additive manufacturing is an appropriate name to describe the technologies that build 3D objects by adding layer upon layer of material, whether the material is plastic, metal, concrete, or one day human tissue. So this is a simple definition of additive manufacturing. Means to build a 3D object by adding layer upon layer of material, whether the material is plastic or metal. So this is definition of additive manufacturing. So advantages of additive manufacturing are freedom of shape, freedom of composition, reducing waste, easy to use, digital manufacturing. So next, policy and homologation certification. Homologation is the process of certifying the vehicles of roadworthiness as the per specified criteria laid by government for all vehicles made or imported in the country. The test ensures that the vehicle matches the requirement in terms of emission and safety and roadworthiness standard as notified under the Central Motor Vehicle Rule 1988. In India, NATRIP is the largest and one of the most significant entities in automotive sector. So far by government to establish and enhance capability of existing the homologation and testing centers across the country. So next is NATRIF has either established or is in the process of establishing world-class facility for homologation and testing of vehicles such as engine, powertrain, passive safety, EMC, NVH, fatigue, certification, material, tires and vehicle dynamics, some of which will be the first such facility within the country. Homologation is the technical term derived from the Greek homologio for to agree, which is generally used in English to signify the granting of approval by an official authority. So next example of tested item. So here are the example of tested item: passenger protection crash test. For and next is child restraints, seat belt, steering system, brake system, field of vision, glass wiper, general lighting, horn, mirror, warning triangles, tires, fuel consumption, EMC, air pollutions, pollutants, noise emission tank, rear view system. They are so those are red, that are passive safety. Those are in orange color, they are active safety. Those are in blue colors, they are components of and system. And greenish are environment. So next, introduction to break even analysis. Break even analysis. This is the break even analysis. So in left side sales are given, and in right arrow units sold, and this is the break even point: total revenue, total cost, variable cost, fixed cost, and profit and loss as we see in the slide. So next, what is break even analysis? So break even analysis tells you the minimum output or sales needed to cover all cost. At this point you neither profit nor lose money. So why important for engineers? Helps in marketing cost effective decisions in project like choosing material, processes or design options. So this is about break even analysis and its importance for engineers. So next, key components. Fixed cost, cost that stay the same regardless of output. Example include rent and salaries. Variable cost, cost that change with the level of production. Examples include raw material and utility bills. Selling price, the price at which you sell each unit of the product. So this is simple definitions of fixed cost, variable cost and selling price. So the formula: break even point in units equal to fixed cost upon selling price minus variable cost per unit. So this is formula for that. Next is examples. If you are developing a machine with fixed cost of $10,000, variable cost of $50 per unit, and a selling price of $100 per unit, break even point equal to $10,000 upon $100 minus $50. So this is break even point of the fixed cost and the break even point equal to 200 units. So next, production capacity planning. So production capacity planning is a critical process in manufacturing and operation management that ensures a company can meet future demand for its products or services. It involves determining the resources required, such as equipment, labor and material, to produce a certain volume of goods within a specified time frame. First is understanding capacity. Capacity refers to the maximum output that a production system can achieve over a specific period under normal working conditions. It is typically measured in units produced per hour, day, or week. So next, second is steps in production capacity planning. First is forecasting demand. The first step is to estimate future demand for the product. This can be based on historical sales data, market research, or future orders. Forecasting helps identify the level of production needed to meet customer demand. Capacity requirement means CRP. After forecasting, the next step is to assess whether the existing production capacity can meet the forecasted demand. CRP involves comparing current production capabilities means included machines, workforce, etc. with the demand forecast. If the capacity falls short, adjustment like hiring more staff or purchasing new equipment may be necessary. So next, third is resource assessment. Identify and analyze the production resources like machinery, labor, materials that are required to meet the production needs. Check the bottlenecks, whether production slow down, which could reduce overall capacity. So fourth is planning for capacity adjustment. Short-term adjustment. Overtime, outsourcing, and temporary hires can address short-term capacity gaps. Long-term adjustment. If demand increases significantly, more sustainable changes like expanding the production facility, acquiring new machinery, or redesigning processes may be necessary. So next is make or buy decision. Introduction to make or buy decision. Make or buy decision arises when a company evaluates whether it is more cost effective or strategic to produce a part or product internally or to purchase it from an external supplier. So the decision is influenced by various factors including cost, capacity, expertise, quality, time, and risk. So come to next slide. Second is factors to consider in make or buy decision. First is cost analysis. Second is capacity and resource and availability, quality control, lead time and flexibility, core competencies, intellectual properties, and strategic consideration, long-term supply relationships. So these are the factors to consider in make or buy decision. Come to next slide. Third is make or buy analysis process. So there are the steps in the make or buy analysis process. First step is define the requirements. Clarify the sorry Clearly identify the part or product to be analyzed and its specification. Consider the design complexity, material requirement, and quality standard. Step 2 is cost estimation. For the make option, estimate the cost of raw material, labor, overheads, and any additional investment required, such as new machinery. For the buy option, gather costs for supplier and calculate associated costs like shipping, quality inspection, and possible tariffs. Step 3 is non-cost factor. Evaluate non-cost factors such as quality, lead time, and strategic importance. Consider the risk associated with outsourcing, such as loss of control, dependence on supplier, or potential delay. Step 4 is decision making. Using tools like break-even analysis or weighted scoring models, companies can compare the total cost and benefits of each option. If the cost of making is less than buying and strategic consideration align, the company will likely choose to make the part in-house. Otherwise, the buy option may be preferred. So, next, Business business case for preparation. So here are the business case for preparation. First is define the problem. Second is conduct market research. Third is set objective and scope. Fourth is develop a solution. Fifth is cost analysis. Sixth is revenue and profit projections. Seventh is risk analysis. Eighth is competitive analysis. And ninth is market entry strategy. Tenth number financial model. Next is implementation plan, conclusion and recommendation, execute summary, presentation, review and revise, submission. So these are the business case preparation. These are the 16 points for business case preparation. So those every point is important for business case preparation. Next is facility tooling and gauges design and development. Designing and developing facility tooling and gauges is an essential aspect of mechanical engineering, especially in industries such as manufacturing and quality control. So facility tooling and gauges design and development, it also plays an important role. So next is vendor development. Vendor development is a strategic process through which a company establishes and maintains relationships with its supplier and vendors to ensure a reliable and efficient supply chain. It involves identifying, evaluating, and collaborating with suppliers to meet the company needs and goals. So next is letter of intent, means LOI. Letter of intent means LOI is a document that outlines the preliminary understanding or agreement between two or more parties as they work towards a formal contract or agreement. It is typically used in various contexts, including business transactions, partnerships, acquisitions, real estate, and other situations where parties want to express their intent to work together. So next is purchase order. Purchase order is a formal document issued by a buyer to a seller or supplier to request goods or services and to outline the terms and conditions of the purchase. It is a critical part of the procurement process and services serves as a legally binding contract between the buyer and the seller. Here's a breakdown of the key elements typically found in a purchase order. So this is about purchase order. So next is product costing. Product costing is the process of determining the total cost of manufacturing a product or providing a service. Accurate product costing is essential for various purposes, including pricing decisions, budgeting, financial reporting, and evaluating the profitability of products or services. So here is the product cost formula. Product cost formula equal to direct labor plus direct material plus direct overheads. So next is product testing and validation. Product testing and validation are essential steps in the product development process to ensure that a product meets the specified requirements, is safe for use, and functions as intended. This process involves various methods and stages to assess the product's quality, reliability, and performance. So next is functional testing. Verify that the product performs its intended functions correctly. This is about functional testing. Next is performance testing. Assess the product speed, responsiveness, and scalability. Next is usability testing. Evaluate the product user friendliness and overall user experience. Next is safety testing. Ensure the product complies with safety standard and poses no hazards. Next is reliability testing. Assess the product durability and longevity under normal use. Next is compatibility testing. Check how the product interact with other system or devices. Next is environmental testing. Evaluate the product performance under different environmental conditions such as temperature, humidity. So next is regulatory testing. So in regulatory testing, ensure compliance with industry specific regulation and standards. Come to next slide. Product testing and validation are integral to ensuring product quality and reducing the risk of defects or recalls. It is a systematic and interactive process that helps in delivering products that meet or exceed customers' expectations and safe for use and comply with relevant standards and regulations. So next is introduction to production part approval process tools, means PPAP. The production part approval process, PPAP, is a standardized framework used in the automotive and manufacturing industry to ensure that the components and parts produced by supplier meet the required quality standard before they are incorporated into the final product. PPAP is a systematic approach that involves a set of tools and documentation to verify and approve the quality of parts during the early stages of production. So this is about PPAP, means production part approval process. So next slide. First is PPAP purpose. Ensuring that the supplied parts meet design specification and quality requirements. Verifying that the production process is capable of consistently producing conforming parts, reducing the risk of defects, rework, and conformities in the final product, providing a standardized approach to communication and documentation between supplier and customer. So next is a core component of PPAP process is the compilation of a comprehensive set of documents. These documents are submitted by supplier to their customers and typically include part submission warrant, PSW, control plan, process flow diagram, FMEA, failure modes and effect analysis, measurement system analysis, means MSA, dimensional results, material test reports, initial sample inspection report, ISIR. So next is so that's all for today's video on design verification and validation. I hope you understand the key concept and how they fit into the overall product design process. If you found this video helpful, don't forget to like, share and subscribe to the channel for more videos on product design and development. Also drop your questions on or topics you want next in the comments below. I shall cover them in upcoming video. Thanks for watching and see you in the next one. Keep learning and keep designing. Thank you guys.